Right, good day. Hope that you're doing well. So in this video, we're going to be doing a previous question paper, paper 2 from your 2021 November paper, right? So now we're going to start off with section A, and to be specific, question 1, which is multiple choice. Now, 1.1 says the smallest particle to be found in sugar that still has the properties of sugar is called Now, what is the smallest particle? This is a molecule. Now, what is a molecule? Now, molecule are the smallest particles of matter that can exist independently, right? So basically, the smallest particle found in sugar that will still have sugar properties, right? It will be your molecule. Why is that? It's because molecules are the smallest matter that can exist independently. So for 1.1, it's gonna be B. Now, particles of a solid, now here they move, okay, haphazardly, do not move at all. They move over one another, or they vibrate around fixed positions in the crystal. So basically, here's particles. So every time whenever I answer, let's say I answer a multiple choice question and I'm not sure with regards to the answer, right? So I would apply my elimination method. Now, how would I go about doing that? So I would eliminate the answers whereby they do not, like, basically those answers whereby they're obviously incorrect, right? And I'm gonna choose between my remaining answers, all right, the one that I think is most correct. Now here, the first one, C, right? So this is obviously not correct. So move over one another. Nope. Now move haphazardly. So A, it's also not an option. So here, I think the two options that I can choose from, it's option B and option D. But when it comes to particles of your solid, they basically, it's not like they move, right? But what they do is that they vibrate, right? So the most correct answer between the two, or rather the correct answer here to be D, right? So your particles of a solid, they vibrate around a fixed position in the crystals. Now 1.3, now the process that takes place when calcium atoms react with oxygen atoms to form calcium oxide is, now what actually happens here? Now when a calcium atom reacts with oxygen atom, they form an ionic compound, right, known as calcium oxide. Now during this formation of calcium oxide, the calcium atom would lose two valence electrons, right, to the oxygen atom. Now this loss of electrons leads to the formation of your positively charged calcium, right? So basically it would lead to the formation of your positively charged calcium and a negatively charged oxide, right? So basically here your calcium would carry the positive charge, right, and your oxygen would carry the negative charge, right? So the reason why your calcium would carry positive charges is because it would lose, right, two valence electrons to your oxygen. So now let's see here. So basically here, A, it won't apply. So two electrons, so B basically says two electrons, one from each atom, are shared between the atoms. Okay, also B won't apply. Now two electrons from calcium atoms are transferred to the oxygen atom. Now 1.3, it will be C, right? So during the formation of calcium oxide, your calcium would lose two valence electrons to its oxygen atom. Now 1.4, this valency electron configuration is possibly that of, so now let me see. So to answer this question, I would need to refer to my periodic table, right? So let me go about doing that. Now here, our exponents, they represent our valence electrons, right? So here, basically this element has 2, 4, 5, 6 valence electrons, right? Electrons. Now I'm going to look into my periodic table and I'm going to show you in which basically column you would find elements with 6 valence electrons. So these row, they have 1, this is 2 valence electrons, 3, you skip your transition metals, 4, 5, 6, right? So now let me see here, what am I given? So I can see sulfur, which I also saw on that row, or on that group rather. So basically here, my S would be the answer for this question, right? So D, this is the valency electron configuration of sulfur, right? So this is possibly for sulfur. Now moving on to 1.5, elements T, X, Z, and Y are respectively in group. Okay, so they give us the group of the periodic table. Now the formula of the compound formed by two of these elements, which is not correct, is, now let me try and highlight these groups on my periodic table. I have group A, so this is my group 1, right, because it has one I, and this because it has two I's, it will be my group 2. So you do not take into consideration the A in this instance, right? So this is where I have 2. And let me see my other options. I have VI. So where's my VI? Here's my VI. And I have V double I think. So let me see, it's V double I. Right. Now, let me classify the ions in each of these groups. Now, for the group 1, right, my ions would be positive 1, so plus 1. Here, they would be plus 2. And my ions here, they are minus 2, right? And here, it's minus 1, right? So now, basically here, let me see what the question is asking for me. So they say the formula of the correct compound formed by two of these elements which are not correct. Now T, right? So let me start with T and Z. T, it's for my group 1 in this instance, right? So this is group 1, meaning that it's positively charged with 1 ion. Now my Z, so let me look at my Z. So my Z, it's from this, right? So let me classify the group. So my Z is from group 6. So let me confirm VI is, right? So my Z is from 6, which is negatively charged. So Z is from group 6 and has minus 2 ions. The electrons would flow from the element with high electrons to the element with low electrons, right? So now basically here, if we take this into consideration too, right, you need to take into consideration the magnitude. So the signs, right, basically they are telling you whether your charge is positively or negatively charged, right? So here we have, so your electrons would flow from your element with high number of electrons to your element with low number of electrons, right? So basically here, because of this minus 2, it means that this, it can lose or gain 2 electrons. Now in this instance, because it will be losing, it would lose these 2 electrons to your T. So as a result, your T would become 2, and this would be the compound for the 2, right? T2Z. Now as a result, this, it's incorrect, right? So let me make an example with the second alphabet B, right? So X is in the second group. So X is in group 2. And remember, in group 2, it's plus 2. Now my Y, it's in the last group here, it's group 7, right? So it's 7. So let me confirm, yes. And here it's negative 1. And remember, we're looking at the magnitude, which is the size, right? As you could see that X has more electrons than your Y. As a result, electrons would flow from X to Y. And because of this 2, this X, it would lose 2 electrons to your Y. So as a result, this would become X and your Y would become Y2. So this would be correct. Now, hence this one was not correct, your A, right? So hopefully it makes sense. Now, moving on to the next question. At STP, right, the molar volume of hydrogen is 22.4 decimeter cubed. The second statement we are given is that, okay, 22 decimeter cubed of any gas consists of 6.02 times 10 to the power minus 3 particles, right? So this is our number of particles, Na, which is a constant. Now let me look into my formula sheet, right? Can you see this is the value here, Avogadro's constant, right? And this applies to your STP, right? So basically the second statement is correct. So let me tick here, the second statement is correct. Same applies to the volume. The volume at STP is 22.4 decimeter cube, right? So if you would confirm here, this is our volume at STP, molar volume is 22.4 decimeter cube. So the first statement is also correct. Now, 22 decimeter cubed of helium consists of 1 mole of atoms. Now, remember when you're dealing with STP, you're dealing with gases. Now, helium is a gas, right? So now at STP, 1 mole of any gas would occupy 22.4 decimeter cube. Now, remember helium is a gas, hence 1 mole of your helium, it would occupy the 22.4 decimeter cube, which is your volume. So this is also correct. So all three are correct. Now, meaning that D would be the correct option for 1.6. Now, moving on to the next question. 1.7, which graph represents the atomic radius R versus the atomic number Z for the element of for elements of period 2, right? So now in your periodic table, your first row would represent period 1, second row period 2, third row period 3, right? Just like that. So this would be your period 4, right? So now here we're interested in period 2. Now remember the question is saying that, okay, which graph, so let me just go back to the question, which graph represents the atomic radius versus the atomic number, right? So atomic radius, which is R, our atomic number, which is Z. So we need to look for which graph which represent the relationship between the two. Now in period 2, right, the atomic number in period 2, they increase from left to right, right, across the periodic table. So basically in period 2, from left to right, so in period 2, the atomic number, so in period 2, your atomic number, right, they increase from left to right across the periodic table, right? So they increase from left to right. Now, as a result, your number, right? So as a result, your number of protons increases, right? So number of protons increases as you're moving from left to right, right? So your number of protons increases, pulling electrons closer to the nucleus, right? So this would make to pulling electrons closer to your nucleus. So in period two, right, the atomic number, right, they increase from left to right, right? So basically, as you're going in that direction, your atomic number increases. And what happens as your atomic number increases is that your number of protons increases, right? Pulling electrons closer to your nucleus. Now, if your electrons are pulled closer to your nucleus, what would happen to your R, right? So your atomic radius would be lesser, right? Because why electrons are pulled closer to your nucleus. So as a result, as the atomic number number increases, what happens is that protons increases, and as a result, they pull electrons closer to your nucleus. Now, what happens to your atomic radius as a result? Your atomic radius, it decreases. Why? Because electrons are pulled closer to your nucleus. All right. So now, as you can see, these two, they have an inversely proportional relationship. Always just know that your atomic number as well as your atomic radius, in period two to be specific, they have an inversely proportional relationship. So now here, so the correct graph here, it will be B. And I want you to note something. Z is your atomic number, right? And if as your atomic number increases, what happens to your R, which is your atomic radius? Your atomic radius decreases. So as your atomic number increases, right, your atomic radius, which is your R, decreases. So the correct answer for 1.7 would be B. Now 1.8, the energy released when an electron is added to an isolated neutral atom to form a negative ion, it's called, so it won't be ionization energy, electronegativity, no, lattice energy, no, but this energy released when your electron is added on an isolated neutral atom to form a negative ion is called electron affinity, right? So the correct answer would be D. Right? So basically, this is the energy released when an electron is added to a neutral atom. So every time whenever an electron is added to a neutral atom, the energy that is released is electron affinity. Now, what is lattice energy? Lattice energy, it is the energy released when ions combined to form a solid lattice, right? Now, electronegativity is a measure of atoms' tendency to attract other electrons in a bond. Right? And lastly, ionization energy is the energy required to remove an electron from its neutral state. Now, the best description here to be D, right? Energy released when an electron is added to a neutral atom. Now, 1.9, this balanced chemical equation represents the reaction between methane and steam, right, which is your water. Now, the volume of methane in meters cubed needed to form 150 meter cubed of hydrogen at the same temperature pressure is. Now, always to answer these type of questions, you need to take into consideration your ratios. Now, here, the volume of methane, right? So this is our methane in meters cubed needed to form 150 meter cubed of hydrogen at the same temperature and pressure. So this is our hydrogen. Now, what is the ratio between your methane as well as your hydrogen? Now, the ratio between these two is 1:3, right? Now, basically, how would I go about answering this question? I would say, how many moles of methane would I need, which is X, to produce 150 meter cubed of H2, right? So now, cross multiplying 3x, it is equals to 150, and everything divided by 3. So as a result, I would say that here I would need 50 meter cubed of methane to produce 150 meter cubed of H2, right? So the correct answer for here, it will be B. Now for 1.10, they give us the formula for your Epsom salt. Now the mass in grams of Epsom salt needed to prepare 1 decimeter cube solution with a concentration of 0.1. So basically here, we're gonna make use of our formula of, so remember, there is only one formula to determine your mass, right? So N is equals to M over molar mass. So N, which is your number of moles, your small letter m is your mass, M is your capital letter M is your molar mass. Now in this instance, I can find the molar mass of this compound. Now, the only thing that I would need here is the number of moles. Making use of this information, I have my concentration as well as my volume, meaning that to find my number of moles, I can use this concentration formula C is equals to N over V, right? So as a result, my number of moles, they would be equals to C multiplied by V. Now, my concentration here is 0.1. My volume, which should be in decimeter cubed, which is 1. And as a result, my number of moles, it will be 0.1. Now, these are my number of moles for my Epsom salt. So now I'm going to substitute them into this formula here. Let me write it here. So my number of moles is 0.1. Now, let me go about determining my molar mass, right? For MgSO4, so let me write it near my periodic table so I need the molar mass of MgSO4. And let me see, what else do I have? 7H2O multiplied to 7H2O. So now I'm going to start with the molar mass of my magnesium, Mg, right? So let me try and look for my magnesium here on my periodic table and highlight it. So this is my Mg, and its molar mass is 24. So this would be 24 plus my S, my sulfur, right? My sulfur is 32, its molar mass, and you have 4 oxygen atoms. The molar mass of oxygen is 16 plus, now this 7 is multiplied to the whole of HO2, right? Or H2O rather. So this is 7 multiplied by H2 as well as 7 multiplied to your O here, right? So now the molar mass of your hydrogen is 1. So basically the molar mass for my 7 hydrogens is going to be 7, right? And remember, I have 2 hydrogen atoms. So this 7, I'm going to multiply it by 2. As a result, the molar mass of my 2 hydrogen atoms is going to be equals to 40. Now, 7 multiplied to your oxygen, which is molar mass is 60. Now, as a result, let me punch this into my calculator to find my molar mass here. And my molar mass would be equals to 246 grams, right? So 246, I'm going to substitute it into my formula here. So this is 246. And I am solving for my m. Now, because this 246 is dividing, to get rid of it so that I could be left with my m, I'm going to multiply it on both sides, right? So as a result, these two are going to cancel out, and this side I'm going to multiply it by 246. Now, my molar mass, or rather my mass, which is equals to 0,1 multiplied to 246, this would be equals to 24,6 grams, right? So basically, this would be option D. Now, in the next video, we're going to be continuing with the other questions, so make sure you stay tuned. Thanks.